All right, so good afternoon and welcome to the Scripps Technical Forum, first one of 2021. So I'm Douglas Alden. I'm a lead engineer with the Center for Western Weather and Water Extremes here at Scripps. In addition, I function as the STF chair and get assistance setting up and running STF from my colleagues here on campus, Gwen Nero and Vanessa Scott. Gwen is the Director of Corporate Affiliates, Business Development, Industry Outreach and Innovation, and Vanessa is an Industry Relations and Innovation Analyst. If you've missed any of our recent presentations, you can find them on the Scripps Technical Forum playlist on the Scripps Oceanography YouTube channel. You can find that on our website, stf.ucsd.edu. We're also migrating into the greater Scripps website, and the email you received about today's presentation has links to that, and that'll be hopefully the new landing page for all things technical at Scripps. Please know that today's presentation is being recorded. You've all been muted when you logged into the conference. If you have a question for the presenter, please use the Q&A function to unmute. And today we're going to have a presentation by Matt Moldovan, who is a former member of the Scripps family. He was here on campus for about 8 years and is now with Suburban Marine and going to talk to us about Baromax underwater connectors. I know connectors have been on a lot of people's minds over the last few years, if not the last few months. But with that, I'll hand it over to Matt.
How's it going? Is the slideshow coming through okay?
Haven't seen it yet.
All right. Maybe I'm not sharing again. Let's get it straightened out. All right.
That looks good.
I'm going to go full screen. Is that better? There we go. Hey, good afternoon. Know a couple of you on the call. My name is Matt Moldovan with Suburban Marine, and we are in the business of underwater connectors. So, like many of you, I've had years and years of trouble getting connectors. I mean, this is a story that's tried and true, and we founded Suburban Marine 2 years ago to provide convenient access to electrical connectors subsea. And we found out that we need to commodify the connector market. We need to make things readily available and not have you wait, what, 10 to 12 weeks for a connector. So we started with a blank slate. We are a self-funded company. We had no overhead, no limiting factors, and we found out that the limiting factor in the lead times and the production capacity of underwater connectors stems from the fact that they can't make it until you order it. So we took a high-level view of the connector system and found out through experimentation and lots of prototypes that if we can just mold the business end of the connector, which is the rubber face, it will eliminate lead times, bring costs down, and get you guys in the water doing really cool stuff. So the way we do that, it's all about number one, the connector face. So we've optimized that. Here you see our 8-pin connector, and from that, you kind of mix and match and build the connector as you see fit. You choose a back shell that would make, in the threaded version, it would make a bulkhead connector. In the bottom one, you see an inline, which would be for making an inline cable. And currently we have dozens of back shells in aluminum, stainless steel. Here you see brass. We have different threads, M10, 3/16. Really anything you want we can make, because we've decoupled our production capacity from having to make thousands of one thing to make it customizable by you. The locking ring, you're familiar with that, it holds it together, and then all you do to make your cables and bulkheads is put it together and pot it with epoxy. You can check out our YouTube channel, and we have some walkthrough videos to show you just how easy it is. So, you know, why am I here? I don't necessarily love connectors, but now I do. We've eliminated lead time to where we stock it. We've done all of the waiting, and we have tons of stock ready to ship at a moment's notice. Our 8-pin can handle gigabit Ethernet, and that's made possible because you're controlling how much untwisted length there is in the connector. You can really push high data rates through it. And I'll show you in a following slide how we demonstrate that. Our contacts, we can handle much higher contact. That's because we have proprietary contact technology in the connector that gives you more surface area. It also gives you higher mating life. And you can do, instead of, I know a couple of you are ganging up different connectors to increase current capacity, you don't have to do that with ours. Another nice thing to have is our locking sleeve helps you unmate it. It's similar to the IE55 locking sleeves, where when you back it off, it disconnects the connector. And we made sure that we didn't sacrifice quality, so we've been testing over the last 2 years in pressure tanks to qualify it to 10,000 psi. And that's not just leak, no leak. We've done hardcore electrical testing to characterize the leakage current at various pressures and various voltages, so that you can take a systems engineering approach to integrating connectors into your housings. So a lot of you won't need that, but if you need it, it comes with the package. So before I did this talk, Douglas asked me to showcase some demonstration, and I thought it was a great idea. So I thought, well, a lot of people are strapping GoPros to stuff. How cool would it be to stream that data in real time? So I started with number one, a GoPro, and thought that I could just connect it over Wi-Fi and everything would be great, and I can showcase our connector, and then we're all done. But GoPro had different things in mind. They've largely eliminated their API so that they make it very difficult to work with them. And a couple different things we discovered. We were violating the rules of the wireless standard by tethering multiple access points in a wireless configuration. Basically, we violated the standard. So we found out we need to add a single board computer to act as an access point for the GoPro. So the GoPro can talk over the single board computer. And then we found out, oh, we need some power for this thing. And showcasing the versatility of our connector, we're using PoE. So it gives you 30 watts unlimited power down below, up to 100 meters run length. And I personally think this is really cool because you can do some real computing. And what we ended up with was this. So you have a PoE injector that goes down, in this case, a 50-meter tether into a Blue Robotics housing, and you have the NVIDIA Jetson Nano in there and the GoPro. And, you know, that traditionally this would have taken a couple months to think of, put together, write some software, have some headaches. And after we worked out the stuff on the bench with the software problems, in a day I had this up and running on the bench, put it in the water. I'm like, oh, that's great. And this is all thanks to off-the-shelf components. And this is really the subject of why I'm here. Suburban Marine wants to enable you to use the industrial stuff that's free. You can just buy it. So my bill of materials is like $500 for this whole thing. And you know, it's made possible by GitHub. There's a GoPro Wi-Fi hack repository on there, and they go into depth and detail about how you can connect with the GoPro, how do you control it, and different things that different versions have had problems with. Grabbed a Blue Robotics housing off the shelf, throw the stuff in there, and then I'm able to terminate my connectors. The 8-pin very easily goes into a patch cable, which I cut, splice, and then I'm able to run Ethernet straight into the housing, unlimited power, unlimited data. And then I go, okay, this is cool. Now what? And so this is where I open up the forum to all of you and say, look, you actually have an edge compute capable platform now, subsea, that can do object detection, classification. Instead of a GoPro, you could have a sonar down there. You can do some SLAM to do navigation subsea, and lots of cool stuff just enabled by using industry standard protocols, having power, and also having the flexibility to build and terminate a connector in less than a day. So it's pretty short and sweet, and we're here to enable you. I really don't want to take up the day with my talk. There were a couple questions that came out. The first one was the most popular question: are we backwards compatible with all the other microcircular size connectors in the industry? And the answer is definitely not. In general, it's not good design practice to mate generics and other things, because we don't control vendors' tolerances. We have our own quality control standards in-house. And if you were to mate our stuff with other people's stuff, that will void any and all application that you have going for you. The next question was, how does the epoxy cure? Is it hard? Is it soft? The epoxy we use is a semi-soft Shore 80, and that's kind of like a bouncy ball firmness. And the reason that is important is because you need something to distribute the stress between an elastomer and metal when you're bonding to them. So a lot of people familiar with like DP420 at Scripps, and that stuff is too hard. So it leads to debonding at the cable jacket, and it's not great for bonding elastomers to metals. So a lot of what makes our connector work is the epoxy. And so that's why we're here, to see what y'all can do. And I want to hear questions from you. I'm done talking.
This is Douglas. I just had a question about the epoxy that you guys are recommending. Is that something that has a pretty quick cure time?
No, so that's kind of where this whole thing took me a couple hours to throw together, and the epoxy cures in 24 hours.
Yeah, I mean, that's pretty standard. It's just air cure. It's not, there's no UV or anything like that.
You can accelerate the cure. Part of the reason, and another question came up, should I pressure pot this stuff or what? And a lot of the reason I've had infinite success potting with gravity fill is because the cure time is so slow. So it doesn't kick for a couple hours. And then after that, after the first 30 minutes, you can cook it in an oven and accelerate it for, you could have it done in 3 hours, but my oven's not big enough for all that cable.
And do you do any vibration on it to get rid of air bubbles, or?
No, so to date, it's been just gravity fill. So any of those things like pressure pot, gravity, that's gonna help.
Mm-hmm.
Our testing has been more focused on real world applications. I know people will do this on a ship. They're going to be in the middle of nowhere. They're not going to have these facilities. So we need to qualify our components with the worst possible process.
Great. Do you have any questions from the forum?
Douglas, I see a question here from Gabriella.
Okay. Oh yeah.
Is there a minimum quantity for purchase, or can we buy a couple to test?
Hey, Gabriella. No minimums. Just go to our website. You can order one. You can order hundreds, definitely we will offer volume discounts if you order many. So just reach out to us. Again, no minimums, no quotes. You just get what you need whenever you need it.
And does anybody is anybody at Scripps currently using them that you know of?
I sent some samples out and haven't heard much yet. So this is our kind of break into Scripps. We've been involved in a number of other industries to date, and thought, hey, why not go into our backyard?
And what other industries have you guys been working with? I mean, do you have other examples of where people have put these out?
Oh yeah, so there's even been terrestrial applications where people need for environmental sensing. You just need a weatherproof connector, so people are using them for that. Definitely subsea use, a lot of expendables, and when you couple the fact that you can really get all these components next day delivery, it opens up the possibilities. So a lot of projects I can't say much about, but they're expendable, and we enable rapid configuration, servicing of components, field repair. I mean, it's really endless.
Great. Well, we got a question came in from Taylor. He asked, can you go into more detail about suggested cables to use for inline potting? And what type of, I expect, what type of jacketing is most beneficial?
Yeah, polyurethane jackets going to be your best bet. EPDM or your normal SOW, the black cable everyone uses, that's great too. Anything like PVC, not ideal, but for instance, I use PVC jacketed hookup cable for the Ethernet bulkheads, and that's fine. So your mileage may vary. This is another cool thing, is some people are using like armored servo cable from Molex for different applications. You can do that. You don't have to ship us a reel of cable and then wait 12 weeks. Just use what you want. Our bulkheads can take up to, hang on, I don't want to misspeak, 18 gauge wire. So that's the limit on what you can solder, and just use what you need.
And is there those kind of specs, like the preferred cable jacketing, is that available on your website?
Yeah, we have a full spec sheet on the website. Go into our, go to the website, go to the fact page or the spec page, and it's right there.
All right, we got a question came through chat from Jacob, and he's asking, what is the pricing structure per unit per 10, and where are the volume price breaks?
Our background is in ordering from DigiKey, right? So, and other major electronic suppliers. So we're structured like that. We start price breaks at 10 and go from there. So you don't need thousands. We want people to order one or two, and if you're doing something really cool, then we can work on price. So we're partnering up with programs like Sea Perch and the Mate programs, and they're not going to use a ton of connectors per unit, but that's really valuable for us to get out in the community, talk to kids about proper engineering practices, system design, system architecture.
So, yeah, so Jacob asked, okay, what is the price? And I just, Jacob, you might want to, I think that Vanessa put up the website, and there's a shop thing. It's just, you can go in there and just scroll through and see all the pricing for these things. It's not hidden behind a quote system like most of the other vendors.
Yeah, so the connector faces, the 8 pins, are $75 a piece, and the back shells, the threaded ones, are $30, and the inlines are 25. You can mix and match. You can, you know, I know you have a very capable machine shop there, so you can actually make whatever bulkhead you want if that's going to suit your need better. And that's where things get really cool, is you're not necessarily tied down by us defining your threaded interface. So if you need like an angled connector and you have the facilities there, go ahead and make it. Because we've done the hard, expensive, painful part, which is making the rubber and testing that.
Nice. Any other questions from the gallery? All right, well, I want to thank Matt for coming and chatting with us today. It looks like some great technology. I can't, you'll have to figure out a project doing more land-based stuff, but there are opportunities for me as well, and you know, these days. But anyway, I appreciate your time today, and thanks for everyone for joining in. We'll have more talks coming up in the coming months.
Thanks, everyone.